Now let us see how V minus E plus R equals to using induction. Let us write our own graph, a planar graph of our choice. Look at this graph. This graph has how many? 5 vertices and 1, 2, 3 regions. How many vertices do you have? 1, 2, 3, 4, 5. Let me say V equals 5. How many edges? 1, 2, 3, 4, 5, 6 edges. And the regions are 3 in number. As you can see, this is actually equal to 2. Now, what is the magic here? Why is this formula always true? You see, when I put another edge like this and introduce a vertex, the number of regions don't increase here. But vertex increased by 1, edge increased by 1. This is like saying when V minus E plus R is what you are looking at, when you increase vertex by 1 and edges by 1, it results in plus 1 and minus 1 to your formula. Think about it. So if I add 1000 rupees to your bank account and then subtract 1000 rupees immediately, there is no change to your bank account. So V minus E plus R was equal to 2, but then addition of a V and addition of an E results in a plus 1 and a minus 1, and hence there is no change in the number 2 here. So whenever you introduce an edge to an existing graph, there is no change to the formula. Now what about you introduce an edge without introducing a vertex? Then let's say you do this, you will have a 4th region here. But then you just added one more edge. So edge went up by 1 unit, the region went up by 1 unit. Then again you have a minus 1 and a plus 1 being contributed, and hence the value doesn't change. Whatever it was before remains to be the same. So whenever a graph grows and you have a big planar graph, do you see that it starts from, let's say, a single vertex, and then you introduce an edge and a vertex, and then an edge and a vertex, and maybe only an edge, I don't know, and then a vertex, and so on. You always introduce a vertex or a vertex and an edge. But we observe that starting from the single node where vertices are only 1 in number, edges are none, and regions happen to be 1 in number, V minus E plus R turns out to be 2 when there's only 1 vertex. And when you introduce one more vertex, edges go up by 1, vertex goes up by 1, the formula remains the same. And at every stage, the formula remains the same, which means V minus E plus R is always equal to 2. And if you noted something, I said I will use induction. Doesn't look like I used induction anywhere. I purposefully did this without talking about induction to give you the intuition that most of the times we need not look at the k equals 1, let it be true for k equals something and then something plus 1, and hence it's true for everything, is a very mechanical way of showing induction. I tried making you people feel for induction the natural way, right? We are actually inducting on the number of edges here, right? We were able to go ahead step by step, introduce a new edge, and still we observed that there is no change in the formula. And hence V minus E plus R equals 2, and you now know induction more than the mechanical way of doing it. This is my favorite example of how induction can powerfully come to your rescue, and induction is actually very intuitive, correct? But I leave it to you as a homework to properly do the mechanical version of induction in solving this formula.